Okay, so the next topic. So as we have completed the MapReduce programming part, next we will go to databases part. Okay, so first of all, what is meant by NoSQL database? What is the full form of NoSQL databases? Have you ever heard about NoSQL database? What is it then? If you have heard about it.
Doesn't have any schema.
Structure. There is no.
Doesn't have schema.
The first thing to understand is NoSQL database means not only SQL. That means you can apply SQL and you may not apply SQL. Both are supported. That's what the fundamental idea of NoSQL databases is. Okay. Now, why this type of databases came into picture 5 or 10 years back? If you look, organization might have only one database, DB2 or Oracle. But now if you look, that is not the case. You will have many different databases, right? So if you want to know exactly that idea, one of the best paper to look is just search in the Google for Martin Fowler, okay, one of the father of object-oriented programming and refactoring, and type polyglot persistence. Okay, I'll explain you this particular word. That's the first hit that you are getting. Okay, polyglot persistence. You know, mono means one, poly means many, polyglot persistence. And if you look at the PDF paper that is accompanying polyglot persistence, you will see the future is polyglot persistence. He just struck off that NoSQL databases, and I want you to concentrate on one particular picture, which is this. So when you go down, you will see this picture that is there in that particular paper, and he has written an excellent book also called NoSQL Databases. So look at that. This is where the industry is moving to. What does that mean? It means that the people are no more satisfied with one database. They have many different databases. Earlier, only one database, that's more than enough. But now, there are technologies came up which is supporting or helping you to implement certain things differently, faster, efficiently in different databases. For example, Redis is a database which is used for user sessions. Okay. Another one is financial data transactions. Nobody can question the capability for RDBMS for transactional database systems. What is this also called? OLTP, correct? Online transaction processing systems. And then you've got React. I don't know how many of you used it or heard about it. It is a beautiful and very powerful database which is used for implementing shopping cart kind of applications. You know, in Amazon, you are very familiar with the shopping cart. You add the items, remove the items, right? Take the total, edit it, etc., etc. React is one database. Then you will see another one. Okay, this is a very, very interesting database which is used for implementing connections, like father knows children, children knows grandchildren, right? Like Facebook connections or LinkedIn connections. Neo4j is an open source graph database that is used for it. And look at this catalog. MongoDB is very good. Reporting, of course, RDBMS is a very good one. Analytics, if you want to do large scale, Cassandra is one. User activity logs, Cassandra is another one. So what he is telling in this particular paper is the days are over where the people are satisfied with one database. Instead, now we have many different databases for different situations. One very important of them is MongoDB, which is used in healthcare and insurance a lot. MetLife is completely implemented using, almost completely implemented using MongoDB database. And if you look at any of the health insurance companies, MongoDB will play a very important role. We'll see the reason later. Okay. So that's what polyglot persistence means, and the very fundamental idea of these particular databases that is getting proliferated in the world is because of this particular reason. I have a couple of slides. You can just to go through this. There is no much thing, but I want to explain on the concept here. Okay, look at this particular database. This is a MySQL database where somebody wants to implement a Twitter kind of feed. For example, tweet is having tags, and for all your tweets, there will be so many posts, correct? So every tag is associated with the post, and you might have so many posts, and posts can have many comments. What is this called? A relational database model, right? And now let us concentrate on relational database model. What is there in relational database model? In relational database model, you have got so many tables. The tables are connected by primary keys, and you will say that if there is a primary key, the other table will refer to it as foreign keys, right? And there are some restrictions or constraints. For example, if this particular primary key is not there in this particular table, then don't insert into this particular table. Oracle example is employee table, DEPT table. You cannot add an employee if that particular department is not existing. Similarly, you cannot add an employee to the department if the employee is not existing. So you have lot of constraints and etc. that things are available in relational database management systems. Relational database management systems, okay, actually what is meant by this relation? Actually that is a word that you should use. I have told you many times before, right? We should not say the word table. Table is nothing but a relation. That is why it is called as relational database management systems. And the rows that you are writing are actually called as tuples, right? That is the official term. And the man who created all these particular rules are called code rules. If you are familiar with the fundamental ideas, there are almost 12 code rules. Oracle supports most of them, about 10 or 11 of that. If suppose a database is supporting more than 10 or 11 code rules, that means it's a very, very stable database, right? And a relational database management system is always transactional. That is why we call it as OLTP. It is very good for reporting, very good for concurrent queries, very good for ETLs, very good for transactions. And the properties that are managing OLTP is called ACID. What is ACID? Atomicity, consistency, isolation, and durability. These four properties must be followed by a relational database management system. What is meant by atomicity? When you do a particular transaction, it should be atomic, which means that either it should happen at the atomic level on that particular row, it should not affect any other part of that particular system. Atomic. Isolation, what does that mean? It should, similar to atomicity, where it should be isolated to that particular transaction that you are doing. Then you have got consistency and then durability. What is consistency? If the table is containing my transactional data of my credit card transactions, if I withdraw $10 and assume that my amount is becoming zero, I should not be allowed again to withdraw $10, correct? That is called consistency. The changes that you are going to make should be visible everywhere immediately. For example, this I might be doing from an ATM, and immediately I am opening my mobile application. That mobile application should reflect that particular change instantaneously in microseconds. That's called consistency. Durability, if you shut down the system and you start again, all that data should be available. It should be durable, it should be scalable, correct? That's what a relational database management system is. Okay? Now, there is another wonderful theorem. Here onwards, you are coming to the concepts. That theorem, you might not have heard about it, is called CAP theorem. What is CAP theorem? Remember the three words in the word CAP. C stands for consistency again. Okay, consistency. A stands for availability, and P stands for partition tolerance. Okay, consistency, availability, and partition tolerance. What is this CAP theorem says? Let me explain what are these words mean. What is consistency? I already explained to you. The moment you make any change, it should be available across all the different systems in nanoseconds or microseconds. Banking, etc. is very, very important. Stock exchange, all these are very important applications of consistency. Availability, it should be available always to access. Okay, every time whenever you are querying, I cannot say that I have withdrawn some money through the ATM and my mobile application is not able to access my account. It should be available. What is partition tolerance? Failure should be managed effectively. If one partition is going down, there should be other partitions which are coming up to satisfy your needs. So, there are three things: consistency, availability, and partition tolerance. And what is CAP theorem says? CAP theorem says that only two of these things can be satisfied at the same time. It is proven. Don't ask me why. It is a proven theorem in the industry that out of CAP, C, A, and P, only two things can happen or be satisfied at the same time. This is the fundamental concept, okay? So, let's take a step back. Partition tolerance is 100% satisfied by all modern systems. If Oracle is down, you have VOAD-HOC, VOAGP1 or VO something. You have got the disaster recovery or COB centers that are all available, right? Immediately it is available for servicing. Partition tolerance is almost 100% available. So it is given that every database system is supporting it. Now you are left with only two. So either consistency can be supported or availability can be supported, telling or assuming that P is always true. If in your project or business requirement you want consistency to be important, go for RDBMS. Consistency, banking, transactions. What will you always use? RDBMS. It can never be replaced. If somebody is telling you big data is going to replace an RDBMS system, the most foolish statement. It's not possible. So, consistency and partition tolerance, always relational database management systems. Now you are saying that, hey, I don't want consistency to be very important. Eventual consistency is okay for me. What is meant by eventual consistency? Assume that tomorrow you want to generate a report of all the claims came today or all the transactions that happened today. Tomorrow you are generating the report, okay? Today's report. Even if it is half an hour delayed or 1 hour delayed, if that reporting time, by that reporting time, if you get all the results, okay, it is fine, right? So their consistency is not more important, correct? Their availability is most important. Why? Because at 8 o'clock, it must be available. So if you prefer availability over consistency, then you will go for NoSQL databases. That's the fundamental idea. Okay. So why NoSQL databases and when you should use NoSQL databases? CAP theorem decides it. Okay. Availability and partition tolerance is your primary concern. That's where you will be going for NoSQL databases. All right. So now you understood that what is NoSQL database and you understood what this particular data is. Now let us look at different types of formats that are being used in the industry. What is a format? Format means the data transfer, how the data is getting transferred. Okay. Assume that this is one system and this is another system. This is system number 2, system number 1. I want to send some data to this particular system. Tell me what are the possible ways. CSV you will send. Any text file you will send. maybe a zipped file you will send. You may use FTP as the protocol. You may use HTTP as the protocol. If you want a secure file transfer, you will use either secure FTP or you will use HTTPS. All these are existing, but people were not happy. Why the people were not happy? Hey, I am sending a CSV file or I am sending an EDI file. Oh, I forgot. This is an 812 or 837 document. This system is sending me. This is NASCO, this is Sapphire, this is provider. This is a transactional system that is happening and it is giving the data. What is this system going to do before sending you this 837 document? It has to generate it. An EDI document has to be generated. Either maybe using Dalbhumi or you are using some official applications or Java code or something, you have to create it. And what this guy has to do? Reverse. You have to parse it and you have to take it back and then you have to put it into your database. And this is what we are doing every day. Correct? So EDI is one format. Expensive. Why expensive? One, all the systems are not supporting. You have to write your own parsers to read it. Extract all the elements of 837 or 812. And then you have to put it individually into the database. Huge process, out of memory. All these problems will come if you are not managing it correctly. So the people came, oh, CSV? Again the same problem. Yes, CSV is easy, but the size is big. And you are sending it through the network. And all throughout our big data, we studied that network communication, input, output should be avoided. So, the people came up with a new approach. Hey, I am going to write the data like this. For example, I want to send a name. So, name, okay, I will write Scott. And then age, I got 50. And I will enclose all these things inside a person tag. This is called a tag or an element. These are all the different tags. A tag can also have attributes. Don't worry about that. Now I am going to send this, and this has revolutionized the world. What is that called? Extensive markup language, extensible markup language, or XML. Every start tag should have an end tag. An end tag will be a slash. It is case sensitive. And the whole world accepted it. And they started writing parsers. There are two types of parsers for XML. SAX and DOM. SAX stands for Simple API for XML. DOM stands for Document Object Model. That is what your talent, ETL tools, everything internally will be using. There are parsers like SAX parsers, Xalan, Xerxes. These are all the Java parsers. All my beginning life in Java was with these things. Today in Singapore, there is a system called TradeNet, which is used by the government, and it was developed by a company called Crimson Logic, where I worked my second job in Singapore. In Crimson Logic, whenever the people are traveling from Malaysia to Singapore, this is Malaysia, this is Singapore, and there is a gate just like Canada and US. And through the gate, if they want to pass, if they have transportable goods, if it is ship or car or anything, that transportable goods should be given to the custom officer. The custom officer will receive that particular document and will send to so many other agencies as an EDI file. 812, 837, Rosetta Net, all these are the EDI documents used in trade and logistics. And then it has to get the approvals, and within 1 minute or 2 minutes, all that approvals should come back, and then this particular person will be allowed to go to Singapore. Otherwise, that person will be queuing there. So that system is using a tool called MHub and T-Hub, a translation hub and a messaging hub. And this was my project. And at that time, I used this Xalan, Xerxes, as well as the parsers for parsing that particular document and completely written using Java. So that is one format. And now the new technologies came in and it is not related with any format. I will come to that format a little bit later. Let's assume that I am creating a web page, a beautiful web page. And today, the web page is having so many widgets. This is your comments widgets. This is your previous job widget. This is your recommendations widget. This is your job offers widget, right? Like that, LinkedIn pages or Facebook pages, you will see so many small widgets, right? Now, when I am looking into a mobile application or a web application, I don't want to wait till this entire page is loaded. That's a foolish design, old design. I want whatever is available, immediately paint it. Then the user experience will be very nice, correct? Immediately when I open to my Facebook, it is showing me my top pages. Slowly it is loading in the background, you never know it. But that's a trick that Facebook uses. What is the application called? If you don't know, you'll be hearing it all these things a lot. React.js. The entire UI is created using React.js. Google uses AngularJS. LinkedIn uses Play framework. All these are doing this particular thing. And can you guess what they are doing at the time? If you want to load that particular widget, they will send a message to the server asynchronously and they will get the data. And that data will be painted here. Then at the same time, in parallel, please think parallel, distributed programming. This also will go. At the same time, this also will go. Whoever is getting the data, it will load. That is how that page is getting printed. Now, what is that technology called? Yes? No, React.js is the UI. What is the technology? No, not MapReduce. What is the technology which is asynchronously contacting the server, getting the data, and then loading it?
Ajax.
It's called Ajax, asynchronous JavaScripting. And when you send the data, how the server is sending that particular data back? JavaScript object notation. It will use this particular format in order to return the data file. So you got a new format now. What is that new format called? JSON. And how the JSON will look like for this particular data? Very simple. Look at this. Name, Scott, age, 50. That's all. Parsing is very fast. And the UI loading, since the data is very small and no much parsing required, and all the browsers support JavaScript, very fast. And it paints the data. That's exactly what is happening in all your web pages. So JSON is another format. So why can't we store the data in JSON? Entire data can be stored, right? So let us create a database which uses JSON as the underlying storage. That is MongoDB. Got the concept clearly? MongoDB uses JSON documents. A JSON document has got collections like tables. Very good. So, like schemas. Collections contains documents. Documents is like table. Documents contains fields. And every field is a key and value. Are you synchronizing the key and value with something else that you studied? So what you can do? MapReduce. See the relation. That is the world. This is that $1 million thing that you need to know, which is not available anywhere. That concept, how you flow. So the moment I have key and value, you know what all can be done. I can partition it, I can map it, I can reduce it, I can do. And not a single MapReduce program is available anywhere in MongoDB, even though MongoDB is created for that particular purpose. So pathetic. You can easily write a MapReduce program in MongoDB. You will write it. So in MongoDB, how the things will look like? Exactly this table. See how it is looking like? No normalization, no backes nor form, No joins, no primary key, nothing. Create everything inside an embedded. Oh, no problem. I will have repetitions. That's okay. But my document is going to be like this. Everything will be encapsulated into curly braces. Inside that I will have an ID, title, and every post will have comments. Comments will be an array. This is Ravi's comments, this is Bhaskar's comments, this is Vara's comments, and then I will have tags. How is your YouTube videos every day? You are writing the tags. You are writing the comments. The people are commenting it. The people are, you are writing the body, which is you are uploading the video. It is internally stored as JSON. And what is the advantage if you store it as JSON? I can write a YouTube video player, a mobile application, using React.js. I can pull the data, paint it. UI became very easy to develop. Retrieval became very easy to develop. Ajax became very easy to develop. Transport became very fast. No expensive parsers needed. Little small parsers only. No huge memory problems. No SAX DOM to be loaded onto the browser. Everything solved. Furthermore, there are some more things. So please by heart this. Remember CDF. Collection, documents, fields. And the field has got key and value. Collection is like a schema. Please always remember. Remember in MySQL, there was a schema called retail_db. That is collection. Inside the collection, remember we had a department table. That is a document. And in the department table, you have rows. So rows is equivalent to fields. And the individual columns equivalent to key and value. That is how you should compare. CDF. Collection, document, and fields. Right? And next important thing, the power is coming here. So let us take a collection. And the biggest difference between NoSQL versus RDBMS comes here. In RDBMS, I want to write the data. What you should create first? You should create a relation, right? You should create a table. What is the command that you are going to write? ADDL. Create table. You cannot do anything into an RDBMS without telling what is the schema. Are you following? Without schema, nothing. But how about Excel file? Do you create a schema before you enter some data into Excel file? Nothing, right? You just open it and you start writing it. So what is the difference between a database and a NoSQL database like MongoDB? This is schema on write. What does that mean? Before you are writing, you have to create a schema. Schema on write. What did you do in your MapReduce? When you put the data, you put PDF. Did you tell a schema? Hadoop FS minus put. Twinkle twinkle little star. How do Hadoop FS minus put? Did you tell before that how your data should be written? No. But tell me, when did you define the schema? When you read the data, correct? When in the MapReduce string tokenizer, first token is twinkle, correct? In the PDF record reader, I read that first word, correct? What is that called? This is the most important factor. RDBMS systems or structured data is schema on write. Unstructured data or semi-structured data. What's the difference between structured, semi-structured, and unstructured? Structured, tables. Semi-structured, think about Excel. It can have 10 rows, it can have 20 rows, but it has some rows. Semi-structured. It is arranged. But you didn't tell how it should be arranged. Semi-structured. Unstructured, PDF, images, MP3. You cannot even know what it is, right? So all structured data in the world is schema on write. Every unstructured and semi-structured, unless you are able to make it schema on read, you can't process it. That's what yesterday we did for PDF. Using Apache PDF box, I made the PDF schema on read. MP3 schema on read. Image schema on read. That is how you process it. How do you think they are identifying face? How they are identifying smile? How you are tagging the face? Using machine learning, of course. So, NoSQL databases is schema on read. And the most important property, if it is schema on read, if it is not schema on write, what is the advantage that you are having? See the power. So, I am going to create a document, okay? In my document, I am going to represent a person. I am writing name is Bhaskar, eye is blue, birthday New York, aliases, location, and the boss name. That is one. Second, please look at this. Name, eyes, location, boss. These fields are not there. Next one. Name and hat. I introduced one more. No problem. Why? It is not schema on write. I can do whatever I want. And now, name, aliases only. Name, what type of pizza he or she likes. Height, location. It all belongs to same collection, same document. Sorry, multiple documents. Because you are not telling create table ename is varchar2 or this data type is this type. You don't have to. You can write it. And now you'll ask, when I query using SQL, let's say I am writing a SQL statement, find all the people who are having a hat. How is MongoDB going to handle? Wherever hat is not there, it will automatically add null. And wherever hat is there, it will return that value. So it manages in that way. And it will add an automatic field called object ID to identify every row. That is used for joins if you want to. This is the power of MongoDB. And now you tell me, why is it used in healthcare? Okay, let me tell you one project that I have done earlier when I was working in the bank. Okay, so there are web applications, right? And can you tell me what are the characteristics of a web application? There will be a WebSphere server, correct? There is a logging location. There is a database associated for a web application. Assume that it is an ETL. Is there a WebSphere server for ETL? No. Instead, you will have a a tool, ab initio, or talent, whatever you like. You will have jobs. You will have the graphs. Correct? That is ETL job. Okay, how about a Unix script? None, nothing of these two. Just a script and which environment to run. Correct? Different applications are there. So I was told to create a UI because the bank wanted to track whether two same groups are creating same application or not. It is cost. So they wanted to create a whole beautiful UI application where you can search for any web application that is existing or any Unix script or any ETL job. If I use a database, what columns I am going to give for web application, what columns I will give for ETL, what columns I will give for Unix. I will have to create 3 different tables then for each type. What did I use? I used MongoDB. A web application will have its own schema. And a Unix script will have its own schema. ETL will have its own schema. And everything is like this, belonging to one particular collection. And then a React.js UI retrieve the data. And tomorrow a new big data application is coming, Hadoop is coming, no problem. See how it is extensible. It can survive years. Even today it is working. And now come to insurance. The type of insurance for a diabetic patient is different from the type of insurance for a cancer patient. The attributes are different. You need data which is completely different for each type of insurance. What is the best database? I'd want a schemaless database. That is the reason why in the insurance sector you will see MongoDB a lot. Alright, so having seen this, what we are going to do is install MongoDB. We all need to do that, and we have to write a particular query as well.
I have a question.
Yes.
Here. See, you are saying we have multiple schemas, right?
Right,
Like
not multiple schemas, multiple documents. Yeah.
multiple documents. When we relate, for example, one person data, if I am trying to retrieve, how that will link with? We have multiple documents with the same name might we have, right? Like the same Bhaskar, we may have multiple.
No, how is it possible?
So all these collections will be in the same.
What did you see about the Twitter? So name is Bhaskar, all the things associated with the Bhaskar, all the things and the repetitions and everything is in one. And that's what I have shown you here.
Underscore ID.
Here, what you told, that is relational. What you asked is relational. Where multiple tables are having multiple Bhaskar is there, and multiple IDs are there, and multiple joins are there, which is the third normal form. Where normalization comes in, and joins comes in. Inner join, outer join, all kinds of complexities. And your reports go slow. Here, I embed everything related with the Bhaskar into one single thing. So that when I query, there is a unique ID for Bhaskar, and that unique ID about Bhaskar is everything. For this particular application, it is everything about that application. That is the reason why it is so powerful. Because it embeds everything and avoids the complexity of your joins, fact dimensional model, Kimball, Kimball models, everything, whatever you studied. Normally you will use a fact and then you will have the dimensions, if you are familiar with the data models, right? The fact is also called as a measure table. So fact dimensional model as well as the normalized model are the two types of Inmon and Kimball models that are used in the data modeling industry. This beats that purpose completely. Right? So let's install. Okay, so please follow, and I'll give you time. First you see what I'm doing. Okay, so I'm going to do that first time. What we need to do is go to this is not in the virtual machine. We will do it in the virtual machine next class. Okay, so go to MongoDB. Second link, the most popular database for modern apps. Download MongoDB. Community server. OS, Mac OS, whatever OS you have, please use it. It is a TGZ file, and click on download. Allow. Quit Safari. The download is completed. I am going to take terminal. I am going to copy or move the MongoDB tar file to here. And that tar XVF, extract verbose. That is the command. It has created a directory, and now I am removing the tar file. And I am going to make a change to the MongoDB. It is 4.2.0 and MongoDB. So I am going to move this particular directory name to be a simple one, MongoDB 420. CD MongoDB 420. cd bin. Bin is the place where all the executable will there. And how will you start the server? Think about God. So that's a command for starting the server. /mongod. Mongod will start the server, but you are going to get an error. Look at the error. Mongod. I want you to create that error. The error will be, if you just come down, data/db not found. Please take care. If you are in Windows, you have to create a directory in your C drive. /data/db means in the root directory. So here, what I need to do, I have to create that /data/db. So what I'm going to do, mkdir, remember, /data, don't forget to put only data. Don't forget to put /data. If you put only mkdir data, it will create a data directory within your current folder. No, / is root. Make it here /data. Permission denied. Why? He's not root. How will you make him as the root? Please come. What I need to do is, please look at that. Yeah. Wait. Users and groups in Windows, you don't have to do this. Click on this and login. After that, go to login options. You will see network account server, join, and then open directory utility. And then if you look here, okay, make the changes again. After making the changes, no, wait. Type the password correctly. And go to the edit and please look, enable root user. This he has not done, that's why it is giving you that message. So enable root user and it is going to ask the password again. Same password and give the verification. Click OK. Yeah. So now it is enabled. Lock it. Lock it. You have to open another command terminal because that session will not be available there. So terminal, cd, MongoDB. Oh, no need to go to MongoDB before you are creating the directory. First mkdir/data. Okay, sudo, first su. Go to the root. See, now you are in the root. Now type mkdir/data. Look. Go to cd/data. Remember, don't forget putting that slash. In Windows, it is in C drive. So when you put it in C drive, it is the root. So cd, before going to cd data, I am changing the permission so that every user can use it. Remember, I am in SU mode now. When I come out, I will become a normal user, right? So every user should have that permission. chmod -R777, -R is capital, -R777 to /data. And no need to do all these things on Windows. And now cd/data. So where are you now? Inside /data. Create another directory. What? Remember /data/db. And chmod -R777 to db. Exit. Now you are back to normal user. Now if you look at cd/data, cd db, it is there already. And now go back to MongoDB, cd bin. Oh, sorry. Now what's the command? Mongod. So I'll make this one small. You should get a message running on 27017. That is a port. 27017. 27017 dot slash mongod. Enter. Look at that. Now there are no errors, and you will see that MongoDB is available on port 27017. These are the steps to install and start the server. Once the server is started, open another terminal. I'll make it small, and don't touch that window where the server is running, the background window, right? Keep it running, unless you know how to run the background processes. So I am covering it. This is a new window. And I am going to go to Mongo directory. And what is the command we typed for starting the server? Mongod, right? Now go to the bin directory and type Mongo, no D. What does that mean? Client. So server is started, and now the client. And you will see your prompt. And on the background window where the server is running, it will tell you, oh, one connection came, connection 1 received. Because one client. Anybody can connect now to this port. If you give 10.1.10.125, whatever port he has, colon 27017, you can also connect. So you started MongoDB. And now what you are going to do? Create a collection and create a document, correct? For that, what you need to do is, please go www.4hoursun.com/passion. Come down, you will see a mongodb.pdf, which is showing you all these steps, little bit older version. Just now we downloaded 4.2, this is 3.4.2, but all the steps are correct. And then what I want you to do is copy this. But remember, from now onwards, whenever I am giving you the PDF documents, when you copy it, sometimes the page numbers and all these things will be there. So unless you copy it correctly, what will happen is that particular page number and everything also will get copied and your command will go wrong. So right click, copy, and come here, right click, paste. Look at that. db.bytes. What does that mean? Bytes is the name of the collection. You don't have to write create collection and all. So I am creating db.bytes, and db is my database. And inside that I am inserting the data, and press enter. Very good. It inserted. So now you got one document. Okay. How will you get it? db.bytes.find. See object ID? I didn't give object ID. Automatically it created an object ID, a unique identifier. So you created it. Now, can I create one more document without gender? Yes. That is what MongoDB is all about, right? There is no schema. So what you should be doing this week, after you do this, remember this page number is there. So if you are copying, if you copy like this page number and MongoDB tutorial will come, your command will go wrong. That's why I am telling you repeatedly. Look at this. I am giving you the screenshot of all these things. After that, insert all these. So one by one, you have to insert all these things so that you will have more data, more documents, right? After all the documents are there, I want you to do all these exercises until page 12 by next week. And you will find out how will you join, how will you write the query, how will you use greater than, less than example, how will you find out occupation of employees who are all developers. You will ask all these questions to me, right? How to write the SQL queries, remember? In the similar way, how will you use? Remember, this is not SQL, so you have to write that syntax. Now, sometimes the command that I have written like this might be wrong. Why, you know? Sometimes this single quote might be double quote. That is because of the copy error. So always refer to the screenshot, what I typed. From screenshot, you cannot copy. You have to write, you have to type it. Because screenshot is an image. Correct. And do it until you reach this particular page. Which one? Page, see, until step 9. This I will cover next class. So this is page 14, not page 12. So until page 14, you can complete all this and find out how you can use it. And I leave it to you. This is my example. Take some JSON document from the web, put that, create, and then try to find out the queries and insert and try to retrieve and all those things.
So here the collection name is bytes, right?
No, no. Okay.
Collection name is okay. Yeah, collection.
Oh, sorry.
Bytes.
Collection name is byte. db.bytes. Yeah, correct.
What is the document name?
Well, I think the document name is what is that? Use bytes. I don't think there is a name as such for a document.
Okay, then not tables.
Right? It is not a table. It is db.bytes.find. From the, what did I tell you? A collection is.
Collection is schema.
So I
document.
think collection should not be considered as a schema. A collection should be considered as a table. Yeah,
it's a table.
correct. Collection is a table. Sorry for that. Yeah, a collection is a table, and the documents. Yeah,
So
you're
there's no
right.
schema, I believe.
Absolutely no. Oh yeah, correct. No schema. My bad. Okay. So collection is the table, and the documents are nothing but the rows. Correct. And each row, each row contains the columns which are nothing but the field, and the field is a key and value. Yeah. Now it makes sense. Correct. Okay. So show collections just like show databases, and you can write use bytes. Then automatically it will be going to that particular byte. So all that basic commands are there. And if you get a doubt, what you will do? Go to MongoDB shell commands. Search in the Google. You will find out. Right? So spend some time on this. And finally, when you complete it, Control C. The client is terminated. You see the zero connection is now open. That means nobody is connected. And then close the server. Control C. So Control C, Control C. Mongod is for server. Mongo is for the client. And where you should execute it? You should execute it from the bin directory. And in Windows, how will you go to that bin directory? You have to open the command prompt and then you have to go there, cd, right? And instead of /data/db in Windows, you should be creating it in the C drive. Okay? Do it on local. Don't do it on the virtual machine, right? And we will be creating a report in the next class by using a reporting tool. And what I'm going to do is, we'll do a small project where we will integrate MongoDB with a Twitter, the social media. We will tweet a message and we will retrieve it into MongoDB. Okay?
Ravi, I have